Here we go. Friday. I started warning you guys that your unit circle is really tough. You know it so well. You say it backwards and not just forwards. No, that's like the alphabet, right? Backwards. Unit circle backwards and forwards means not only be able to take something like cosine of 45 degrees is square root of 2 over 2. Which means cosine of pi over 4 is 45 degrees, so it's going to be the same thing. What was the answer a second ago when you considered square root of 2 over 2? Right? Not only do you need to take something like that and answer it like we kind of did yesterday, reviewing unit circle just a little bit in the back of our spirals, remember? But you also need to now be able to say, like in the page before, the examples we ended with yesterday, cosine inverse of root 2 over 2 is. Why are there two answers? Two possible. Yeah, they're both the same answer, just one's in degrees and one's in radians, and I didn't give you any directions as to which one to use. So either one would give. And some of the homework for 4-7, could there be more than one right answer? Yeah, as long as one's degrees, one's radians. How do you know which one you're solving for if you are using your calculator, for example? Check your settings or your mode, right? Technically. Check your mode and see which one you're in. If you're in the unit circle, it's kind of like whichever one you decide to put down. Unless they give you directions in degrees, in radians. And if it's a quiz tomorrow, wouldn't the multiple choice answers dictate which one you use? For inverse trig, if all the multiple choice answers have degree marks, well, you better give me a degree answer, right? And if all the answers don't have degree marks, you probably will, first of all, you'll probably see some sort of multiple of pi. And second of all, you'll know it's in radians. Okay. We're going to go back to these examples in just a second. Before we do, though, let's go ahead and finish this page you guys were working on. So normal trig says, give me an angle, I'll give you a ratio. So for sine, I'll give you opposite over hypotenuse. In the unit circle, it's one number. It's in, for sine, the y spot. Or for cosine, it's in the x spot. Or for tangent, it's the y over the x, the sine over the cosine. But for inverse, it says, no. Give me just like we did for inverse sine. Give me the ratio. Give me the value. And I'll give you, or hopefully you should find, the angle. Inverse is saying, give me the ratio, I'll tell you the angle. If it's unit circle, I'll know it. Hopefully. I'll remember it. If it's not unit circle, like, these 50 numbers, I'll have to use my calculator. But if it's unit circle, I'll know it. Because I'll just go backwards from the unit circle. If it's 50 numbers, well, I'll have to use my calculator. Give me a ratio, I'll give you an angle. And guys, whether it's arc cosine, one more time, whether it's arc cosine or whether it's cosine with a little -1, that does not mean the reciprocal. They both mean the same thing. We're going backwards. Give me a ratio, I'll give you the angle. For cosine. For tangent, same dealio. Give me a ratio, but this time it would technically be an opposite over adjacent, so pick the left, right? Give me a ratio, I'll give you an angle. And arctan means the exact same thing, just another way of writing it. Give me a ratio and I'll give you an angle. Okay. Remember. I think I did this yesterday too. Secant equals 1 divided by cosine, which is not what is it? Not cosine inverse. What is it? Not cosine inverse. What is it? Not cosine inverse, right? How do you do secant in the calculator? 1 divided by. How do you do cosine inverse? Switching the x and y going backwards. Second cosine. Two very, very, very different things. I know I'm making a big deal with it, but it's such a common mistake. Cotangent. Who is cotangent? Help me. 1 divided by tangent. What is that? Not. Not tangent.
calculator, we did tangent of x and then outside of parentheses to the negative first. Is that?
Because that notation is saying, hey, raise it to the negative 1 power 1 over. But the notation tangent with the negative 1 inside the second tangent is the funny. Okay. With that, we have to review, we have to remind ourselves of the restrictions. Just one more time. For any angle in the unit circle, there are infinitely many co-terminal angles, angles that would end at the exact same place, and we don't want infinitely many answers. We need just one. It's called the principal value. And since both of these are tangent inverses, whether it's written like that or whether it's written like that, we have to go back and remind ourselves for y equals tangent inverse. I want you guys to go keep your notes back up just a little bit. Can you guys figure out what angles I'm allowed to be looking at? You should be able to tell because they're angles in the little interval notation. Go look underneath tangent inverses graph. Domain and range. Negative pi over 2. To pi over 2. For those of you who are visual people, let me show it in the unit circle. They're open because tangent has vertical axes. Let me show it in the unit circle. You're only allowed to, my degree people, you're only allowed to go down 90 degrees. My radian people, down pi over 2, or up 90 degrees, or up pi over 2. We're only allowed to look in quadrants 1 and 4. Question, to get to quadrant 4, are we allowed to go the long way? What do we have to do to get to quadrant 4? Go negative. Okay? We're not allowed to go the long way. We have to go negative, the short way. All right. Help me out. Tangent inverse of negative 1. For those of you guys, can I quickly see raising hands? How many of you guys do actually like using the table for these? Oh, really? Okay. You don't have to. I've been referring to the table and I just feel bad because I literally haven't shown this inverse trig what to think about. I'm going to go slow and steady that way. That wins the race, right? 45, 60, 90. My table people, how's it go? 1, 2, 3. Then we end with 1. No. 3, 2, 1. 0. Square root of 3 over 3. 1 square root of 3. We've done this. You guys know what this is. It makes sense. So you still use it. Tangent is a little harder. Because tangent, even my ones that like the first quadrant and go around, that's really great for sine and cosine. But you probably don't really have memorized the different tangent values. So tangent's a little tricky, but the table is actually kind of nice because we just need to say, when will tangent be 1? 45 degrees. When will tangent be negative 1 if we can only choose first or fourth quadrant? Right? We're not going first quadrant, everything's positive. Where are we going? Fourth quadrant, what reference angle? 45. Oh, hey. And I'm not even going the long way, I'm going the short way. So the short way is, Tyler, you already said it. What is it? Yeah. I'm going down 45 instead of up 45. And if we're needing to go into radians, what would that be in radians instead? Negative pi over 45 is 1/4 of 180. Negative pi over 4. Or 1/4 of my calzone or of my pi. So whenever you're doing inverse trig, you have to ask yourself the question, now, tomorrow on the quiz, no calculator, it's not going to be a yucky number. It's going to be a number that's from the unit circle. Whether it's inverse cosine, inverse sine, inverse tangent, it's going to be one of those values, just a positive or a negative, and you need to know where to map it to, or how to answer. You need to know which quadrants are allowed, and then look at the sign and say, well, it's not first, it's negative. It must be fourth, and then which one? Is it negative 30, negative 45, negative 60, negative 90? Just figure it out. Now, our tangent means tangent inverse. Square root of 3. If you use the table, awesome. Or square root of 3. 60. And am I going positive or negative? Oh, yeah. First quadrant, 60 degrees, or if we were to be super snazzy, pi over 3. Now, my non-table people. For inverse trig, it's a little hard. It's not impossible, but it's a little hard. Tangent, we have to think about tangent equaling y over x. So, if we were to take, for instance, the 1, y over x needs to equal 1. You would have to think in all of your ordered pairs, think, when is y and x the same? Square root of 2 over 2, square root of 2 over 2. Aren't those up to 45s? That's when it's the same. That's when if you put them over each other, it would be 1. So that's how we would get to 45. We would still have to go fourth quadrant because it's negative and we're only allowed to go up 90 or down 90 for our tangent inverse. But for the next one, you'd have to say, well, it's positive. I know it's in the first quadrant. I know my y is square root of 3, which is taller. I know my x is 1, which is shorter. And what angle's up high? With the high opposite side but a smaller adjacent side? 60 degrees. So it's a little bit of a struggle. You might want to think about your point. Your x is 1/2. Your y is root 3 over 2. And when you divide the 2's cancel, you get root 3. So my non-table people, it's not impossible. You just kind of have to work a little bit harder on inverse trig. But most of you guys, you already punched in your calculators because you see the next two problems. Tangent inverse of 113. Isn't that a little high? We saw it yesterday. For our cosine, our sine, you had to be in between 1 and negative 1. I bet it's an error. But it's not an error. Because tangent is allowed to keep going how long? He goes forever this way, so when we flip him, what's he still do? He goes forever. He doesn't have an error. He's fine. Whatever number you want to put in, it's going to work. And so those of you guys that put it in, someone in radians, what'd you get? 1.9. We'll leave it at that. Someone in degrees, what'd you get? Oh, no one's in degrees. It's not a horrible thing. Do you guys change degrees, or someone had it? Technically, both answers are right. The only time when you might be wrong is if the directions told you which one to use. Our cosine of 0.264. Why is that so small? Oh, that's right. Cosine sine has to have values in between 1 and negative 1. Otherwise, it's undefined. Someone in radians, what'd you get?
1.3162334.
Someone in degrees, what'd you get?
74.692.
7.4 or 74?
74.6924589.
Yeah, 1.3056. Sorry, my marker's starting to die and my board needs cleaning. Can we go back for a second then? Does it make sense why, if you look at the table, maybe some of you should transition to using that. Where is cosine square root of 2 over 2? 45. First quadrant or what's cosine's restrictions? 0 to pi. Right? What two quadrants am I looking in? The one between 0 and 180. So, quadrant 1 or quadrant 2? Well, it's positive, so quadrant 1. Everybody's positive in quadrant 1. So pick the 45 in quadrant 1. Well, it's 45 degrees or pi over 4. Why on earth is this one in quadrant 2? Oh. It's allowed to be in quadrant 2, and what was cosine sine? Cosine SIGN. Negative. So it couldn't be in the first quadrant, it must be in the other one. And why did I choose 120? Well, because what's my reference angle? When is cosine 1/2? At 60. And what's a 60 degree in the second quadrant? Well, it's 60 plus 60, which is 120, right? And 120 as radians would be 1 pi over 3 plus 1 pi over 3 is 2 pi over 3. All right. What are some important things to know for inverse trig? It's restricted. It's only allowed to be in certain quadrants. Where is inverse sine allowed to be? You know, 1 and 4, up 90, down 90. Where's our cosine allowed to be? 1 and 2, 0 to 180. And where's our tangent allowed to be?
Everywhere.
Huh? Well, he's allowed to have anybody plugged in, but who's allowed to come out?
Oh.
Only 1 and 4. What helps me know which quadrant? The sign, positive or negative. What helps me know what angle? How well I know the units. Either in a table or with it. So you gotta go backwards. Basically, guys, that's it. With inverse trig with numbers. Now, we do need to finish off. Remember I said the rest of class would be homework help. So let's go ahead and do some examples of how to apply this concept. Oh, sorry, it's on the ceiling. How to apply this concept. How to apply this concept. We have the main idea, I hope. At least we've looked at it for 2.5 days now, or 2 days. So now we need to apply the concept. All right. When I'm given something like the following, and I need to solve. Let's start with solving for theta. We've done a lot of right triangle stuff where we've solved for sides, like with Pythagorean theorem. Or we've solved for one side, but we know an angle and we know like an adjacent, we need an opposite. We're like, ooh, tangent, let's use that and solve. But we haven't really seen anywhere we don't know the angle and we know the sides. Like, let's say we knew like 4 over 3. Now we could figure out the hypotenuse, it's 5, but that's not the point. The point is who is theta. How would we have to set this up to solve? We could use sine, but let's say since we have opposite and adjacent, we use those. Tangent. So tangent of theta is equal to 4 over 3, yeah? Well, what's the problem? How do I get to theta? He's inside tangent. Oh, divide by tan. That makes no sense. Tangent needs somebody with him. He's hanging there good. We need to go ahead and get rid of tangent. Shh. Get rid of tangent. How? Here is an application of tangent inverse. It allows us to undo, but what we do on one side, we better do on the other. Right? So to solve for theta, to figure out the angle, we can use the inverse trig to go backwards from opposites over adjacents, or opposites over hypotenuse, sine inverse, adjacent over hypotenuse, cosine inverse. We could also, that's one application, we could also simplify something that looks kind of crazy. Kind of crazy like this following. Ew. Well, hold on. Doesn't an inverse and a regular cancel each other out?
Yeah.
Like, okay, we did this before. It was actually in the definition of inverse functions. Remember how for inverse functions, f of f inverse, they're supposed to cancel and just equal the inside. Or f inverse of f, they're supposed to cancel. That's part of the definition of an inverse. They undo each other. And so we did things like this all along the way. If we had something like e to the ln of x, question, what would that equal? X, because e and ln cancel out. What if I had ln of e to the 2x? What would that equal? 2x. The ln and e cancel out. What if I had square root of x squared? What does that equal?
X.
Because they undo each other. Ln and e are inverses. Square root and squared are inverses. Now here's a weird one.
What's minus?
What's the square root of x squared? Oh, it's just x, almost. It's absolute value of x. Because when you square it, it's positive, and square root of a positive is a positive. I'm not allowed to have a negative. And here's the crazy thing. They cancel out. Yes. But there's something special we have to remember. Now, this isn't the point of this section. What I'm trying to tell you is, yes, a function and its inverse cancel out. But sometimes there are special rules, properties of different functions that make the answer a little trickier than just writing 5 pi over 3. is he allowed to be? He's only allowed to be in between stink. Is 5 pi over 3 in between negative pi over 2 and pi over 2? He's 1 2/3 pi. That's a whole lot more than a half. So what are we going to do? We're going to say yes, they cancel, except where is 5 pi over 3? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Right here. I can't go that way, but what way can I go? Negative. So instead of going to 5 pi over 3 and saying, oh, it's just that answer, I have to say, but what's the allowed version that gets me to the same place? A bit of a struggle. However, look at the next one. Okay, function and inverse, cancel out. Ooh, but wait, where's cosine inverse allowed to be? Allowed to be between 0 and pi. Oh! Was that okay? Okay. Can you guys throw in your calculator really quickly? He looks okay. It's a pi, right? Except, is pi what's allowed to go in or what's allowed to come out? Is pi the domain or is pi the range? What's allowed to come out of a cosine inverse is 0 to pi, but they tricked us. This pi is going in, not coming out. What's allowed to go into cosine inverse? Negative 1 to 1. How big is pi? 3.1415926. Is he in between 1 and negative 1? So what happened when you plug it in your calculator? You try to find it. Error. Why? Pi doesn't work in the domain. So there are two different ways that this could have some issues. One way is it's very possible. There is an answer. But it's just not the same one you would think because it's not allowed. It's not in the acceptable range. So we have to map it on the unit circle and figure out another way of getting there that's legal. Going to negative pi over 3. But another way that you could have some issues is if there's an illegal value that doesn't even exist. You could say, cancel out, it's pi. And you'd be wrong also. So I showed you two tricky ones. Can I show you an easy one? Is that cool? We're going to have to give you something like arc. Let's do cosine inverse. Cosine inverse of cosine of 2 pi over 3. I showed you the two tricky ones. I could get a little weird. But what if it was something like this? Cosine of 2 pi over 3, it would equal something. Cosine inverse would say, let's go back to the angle. Well, who's the angle? 2 pi over 3. Is he allowed in our 0 to pi?
Yeah.
Sweet. Cancel. 2 pi over 3. Done, done, done. As long as everything is legal, I'm fine. We just have to watch out for the times where there might be something illegal, like a number too big going into cosine inverse, or an illegal value coming out that I have to change. But as long as it fits in the acceptable range, and as long as there's nothing too big going in, I'm cool just to cross out and say, okay? Application 1, how to solve for an angle from a triangle. Use the inverse to go backwards from a ratio. Application number 2, how to simplify crazy compositions of inverses with originals. Sometimes they're possible and sometimes they're not. Usually they're possible. But every now and then they get a little tricky. Last application. Last application, then a calculator trick. And to be honest, we could save the calculator trick till tomorrow because the quiz doesn't have the calculator on it. So the calculator trick is more kind of for the final. And for 2 questions in homework at the very, very end that you might get confused on. Okay, last application. Last application. Solving for a ratio of a triangle with a given expression for 2 sides. Whenever you see one of these weird composition-y things, and you see the arc sine or the sine inverse. Question, is this representative of an angle or a ratio? If it's going inside the inverse. It's a ratio. It's one of these, right? It's one of these, not one of these. It's a ratio. Well, what ratio would be sine? Arc sine. It must be a sine ratio. So Katoa, sine is who? Opposite over hypotenuse. What? Yeah. Opposite over hypotenuse. If it's a ratio, then I could make the top one the opposite. I can make the bottom one the hypotenuse. I can name this theta, and here's my little unknown. The question, kiddos, how do we usually find an unknown? When we have 2 sides, or at least stuff that represents 2 sides. Pythagorean theorem. Pythagorean theorem says, okay, take one side that you don't know, plus the other side, whatever, they gave me a letter for it, and set it equal to leg squared plus leg squared equals hypotenuse squared. Oops, sorry. It's 2 squared, which is 4, right? There we go. How do we solve for the missing side? Wait, why are we solving for the missing side? What's the point? Why do we need adjacent? I need to find cosine, and cosine says, hey, please give me adjacent over hypotenuse. And you're like, stink, but I only know opposite over hypotenuse. Now, it's not even going to be a number, guys. It's going to be like a formula, because there's an x in there. But how do I find the adjacent side? I need to solve. How do I solve? Question mark gets a little confusing, right? Let's make it like a little a for adjacent, because that's who we're solving for. Let's solve for a, which is going to end up, just to be quick, 2 squared is 4 minus x squared plus or minus square root. Plus or minus square root. And I think the book usually is going to keep the positive square root unless it tells you like a quadrant. If it says like, hey, you better look in quadrant 2, you're like, oh, state cosine has to be negative, so choose the negative. If it tells you quadrant 4, cosine is positive, okay, choose the positive. If they tell you what quadrant, then you're allowed to choose a sign. But otherwise, usually we'll just keep it positive unless they tell us something that says, oh, you better be negative instead. But if I know who A is, I can say, sweet, cosine equals, more specifically, cosine, when sine is x over 2, is always going to be adjacent over hypotenuse. I just want to let you guys know that that could be an answer. It has an x in it, but there was an x in it to begin with. We don't know what the x is. They didn't tell us. They just said, okay, if this is true, opposite. If this is true, hypotenuse. Find a formula for adjacent. Okay, the one thing we didn't get to, a calculator trick for how to do arc cotangent, arc secant, and arc cosecant. It is going to be in your homework tonight. You are going to see it. However, remember, is there a calculator allowed on the quiz tomorrow anyway?
No.
No. So we're not going to have to stress about that one for the quiz. So maybe we'll look at that after the quiz. I don't think I gave you guys one of those problems. Homework 30 you're working on tonight, okay? Now, what did we not get to today, sadly? The evens to 4, 6. We didn't get to the evens to 4, 6 to grade them. Trying to think of what the best way to do to have you guys see this. I'm going to go ahead, kiddos, online. You know how we have a shared folder, yeah? Okay. if we go to our shared folder, let me actually go backwards a step. If you notice, there actually is a place in our shared folder, and here's why I'm telling you this. I'm going to save as a document just the even answers to 4, 6, and 4, 7. Some of you might not even look at it, so like, well, I can check the odds, and that's enough. I have the idea in order to do like a kind of brief overview little quiz tomorrow. And if I work with my group, we'll be all right. But if you do want to check the evens, 2, 4, 6, and or 4, 7, the homework you're doing tonight, if you look in your shared folder, I'm trying to show you where I'm going to put it. Do you see handouts? If you go under handouts, I might go and just throw it in there with the graphing calculator handbook. Sound good? Just because it doesn't really work under homework sheets, those are problems. It doesn't really work under notes. Actually, maybe I'll just throw it right here in the beginning. Is that easier? Okay, I'll just throw it in here. I wanted to throw it in handouts. Now I'll just say homework number 29 and 30, even answers. I'll name it that. Homework number 29 and 30, even answers, is in your class shared folder. You'll be able to find it if you want to reference it. Does that sound good? Yeah. That way you guys won't be without the even answers and you'll be more ready for tomorrow. It's just me or the bells really weird today. Right? Is anyone else leaving? Oh, there are people. Go. Beep. I don't know why it didn't ring. Bye guys, see you tomorrow. Work on that homework. Bring your notes all updated. Let's get some more good grades in before the end. Okay, let me save this.
High school career.